Hello students, and welcome to our continuing lesson on exponential growth and decay functions. And now we're going to deal with number 6. Carbon-14 has a half-life of approximately 5,730 years. So this word here, half-life, I'm going to define that in a minute. A fossil is found that has 35% of the carbon-14 amount compared to the living sample. How old is the fossil? So carbon-14 is an isotope of carbon. It's got 14 neutrons. And it has a interesting behavior in that it decays over time, over a long time. And it takes it about 5,730 years to get down to half of what it used to be. So this is sort of an informal definition, but it'll be good enough for us to work with. This is the amount of time a substance decays, or the amount of time that a substance to half its original mass. Okay, so we'll do a quick example. If I start with 20 grams, and after 9 years I have 10 grams. Okay, so this is 10 is half of 20. Then the half-life equals 10 years, or 9 years. In 18 years, I'm going to have half of this, so I have 5 grams. In another 9 years, in 27 years, I'm going to get half of this, which is 2.5 grams, and so on. Okay, so that's just the kind of a quick introduction or review, hopefully, into half-life. My guess is if you're in high school and you're taking pre-calculus, you're probably taking chemistry or physics already, and I'm sure this has been discussed in those classes. So now we'll return to the example. So this particular problem says that carbon-14 has a half-life of 5,730 years. Okay. And so for these problems, you may have seen this from the previous lessons, we're going to make a table. We're going to make this here, this t here as time, and we're going to make f of t is the amount. And so when we start out, time is equal to 0, and we have 100%. Okay? So then one of the interesting thing about this problem is that we don't really know exactly how much we start with, but we have 100%. Okay? And then after 5,730 years, we have 0.5, or half of what we used to have. So this is 50%, right? This is the half-life. And one thing we don't know is, what happens, how long does it take for us to get down to 35%? That's what we don't know. But we can continue this pattern, right? In another 5,730 years, so this is 11,460, we're going to get half of this number. So we have 0.25. And you can continue this pattern on and on forever, but we're interested in this particular case when there's only 35% of it left. Well, at this point, you can probably guess that we're going to be writing an exponential function. F of t is equal to a times b to the x. To the t. At 0, there's 1, so when f of t equals 1, t equals 0. That just means that a equals 1. So this makes things very convenient for us that we have a 0 point here. And then we can use either the half-life or the half-life of that number. Either one will work. I'm going to use this one instead. So I know that when f of t is 0.5, t is equal to 5,730. And I can effectively get rid of this 1 here, because 1 times b, it's just the same thing. If I want to get rid of this number here, you have to raise both sides to 1 over, so this is an exponent here, 5730. 1 over 5730. And so the results are not going to be pretty, but it'll work. 0.5 to the 1 over 5730 equals b. So our final function is f of t is equal to 0.5 raised to the 1 over 5730 to the t. And what I could do is multiply this t out here. Either way it works, or just leave it like this, still works. And then I want to solve what happens, what's the value of t when f of t is 0.35. So when f of t is 0.35, what's this going to be? And if you remember how to solve this algebraically with logarithms, that's excellent. You should definitely practice doing that. For now, I haven't talked about that yet, so we are going to solve this problem graphically. So my function is 0.5 raised to the 1, or to the t, to the x, or t here, divided by 5730. And the other part is I'm going to look at for 0.35. Now let's think about our window here. That's always the tricky business when we have to deal with functions or graphing. Well, remember that x represents time. So time is going to start at 0, and it's going to go how high? Well, it's not going to go higher than this number here. This is 11,460. Okay. I know that between 0, I mean the time's going to start at 0, but when time is 11,460 years, the amount is already down to 25. So when it's 35, it's going to be a little bit shorter than that. So that's the biggest number that it can possibly get for this particular problem. So I'm going to go to 12,000. Okay, I'm going to increase by 1,000. Well, the y value is going to start at 0, and the biggest that it's going to get is 1. I mean, the y value is never going to get bigger than 100%. So I'll just go up to 2 here, and just to give myself a little bit more room, hit graph. Okay, you can see the lines being drawn there. There's the red line and there's the orange line. And now I can hit second calc, find the intersection. And you can see that it's about 8,678 and a half years. So my final answer is about 8,678 years. Okay? So in other words, if you find a fossil with 35% of carbon-14 remaining, it's about this old. Okay? And in fact, this is how scientists, archaeologists, biologists determine the age of various fossils, because carbon-14 is an isotope that happens to exist in all living beings. Thank you, students, for watching. Again, these problems are not terribly difficult, but I can see how they can be tricky. They can be overwhelming. You just have to continue working at this, ask for help, be honest with yourself, and always ask your teacher for help if you really do struggle with it. Have a wonderful day.